Okay, see Lindelof videos, triangle inequality theorem, which just begs the question. It talks about this relationship that triangles have to have about lengths of sides, and whether or not if I have these three different lengths, if I can make them touch, if I can get this and this to touch, if I move this down. And there are some ways to test this, so we're going to talk about that today. And the other thing we're going to talk about is if I have two given lines, so if I have this line and this line, what's the range of lengths of line that the third line would have to be? And the reason we're covering these two ideas is because those are the ones, frankly, that you're going to be tested on. So I'm going to do two questions of each. So let's get started. So here we are. We're trying to figure out if I have lengths, one side is 7, one is 5, and one is 4, is there a way that I could put these together and get a triangle? So I'm going to pretend for a second that I can. So this, obviously this is not to scale, so I'm going to just label the vertices any way you want. I'm going to label this vertice A, B, and C, and then I'm going to just assign lengths here. So I have 7 here, maybe 5 here, and 4 here. And this is what we say. This is how we're supposed to be able to figure this out. We're saying line segment AB plus line segment BC has got to be greater than line segment AC. There are three arguments. So that's the first one. The second one is that line segment AB plus line segment AC has got to be greater than line segment BC. And then the last one is line segment AC plus line segment BC has got to be greater than line segment AB, right? So what this says is that the sum of any two line segments has to be greater than the third one. So that's what we're testing here. Is that true? So this actually, first off, I would definitely make a triangle, make a picture so you can read from it. Also, teachers love that junk. So I'm going to start testing here. Line segment AB is 5, so here's my 5. I'm not going to describe this too much in the second problem, but line segment BC is 4. And AC is obviously 7. I'm going to check this math. 5 plus 4 is 9. 9 is greater than 7, therefore this one works out. All three of these conditions have to be met, not just one. So I'm going to keep going. Line segment AB is 5. Line segment AC is 4. And line segment BC is, AC, man, I'm dumb. AC is 7, sorry, 7 has to be greater than 4. This is 12, 12 is greater than 4. It worked out, right? So then AC, again, AC is 7 plus BC, BC is 4, is greater than 5. So the answer is true. So these three conditions, so if your teacher, professor, whoever you're doing this course with, asks for proof, this is what your proof looks like. This is the proof. So if it's a proof, so here's your proof, and the answer is yes, these three lines can make a triangle. These three lines can make a triangle. So I said we're going to do 2 of these and then 2 of the others, so let's do this. Again, I'm going to assume, just so I can diagram here, this is actually true. I'm going to label this A, B, and C. Remember, these three conditions we have to meet are the same every time. So what you really need to know is what conditions have to be set up. I'm going to name these sides 6, 3, and 2 for no other reason than I feel like it. Right? It doesn't matter. You can't go wrong when you label it. Remember, we said that the line segment AB, right? This is the inequality theorem. AB plus BC has got to be greater than AC. And me, I always write these in the same order just because I'm trying to make sure I cover it all. Then I'm going to write AB again. Line segment AB again. I haven't used AC here, so AC is greater than line segment BC, right? And then lastly, the line segment AC plus the line segment BC is greater than the line segment AB. Check me out here. This is important. That I'm trying to make sure I have all the possibilities listed out. So I'm like, okay, I have AC here. I can't have AC again. I have BC here, so I can't have AC or BC, which leaves AB. Sounds dumb, but like in the heat of a test, like you get confused. You're like, damn, if I didn't just do the same thing twice. So just a way around that. We know that AB is 3. We know that BC is 2, and we know that AC is 6. Holy sh! Right? So check this out. 3 plus 2 is 5. And is 5 greater than 6? It's not. So no. So here, you can go to this proof, and you can just stop here and say no. If you care to know, these other two conditions actually do meet, but all you have to have all three of them. So if we had done this in reverse, would have been like, oh yeah, check mark here, yeah, check mark here. As soon as the condition is not met, any of the three conditions is not met, you can stop, and the answer is no. All right. So I said that we do 2 of this type. We had one where the answer is yes, where it actually works, and then we found another one, which just means if we had a 3-mile line and a 6-mile line and a 2-mile line, and we tried to connect them and make 3 vertices, we could not. They couldn't meet. All right, so on we go. So the next one I said that we would do is, given 2 lines, what would the third line be? Let me tell you what they're going to do, because they're jerks about this. Is they're not going to tell you that. So they're going to say 2 sides of a triangle have the following measure. Find the range of possible measures for the third line. So it's really stupid, but they're not going to tell you. So they're not going to say, hey, so put an X in here or put an L in here. So they're going to give you these 2. Just do me a favor and just add. I always add X, but you can use any variable that you want, because now you have 3 sides. You have the first side, the second side, and the third side, which is the one you don't know. Always drawing a triangle. Going to label my triangle out A, B, and C. Remember, it doesn't matter the order of these, right? I'm going to put the 9 in here because I feel like it. Maybe the 5 goes here, and maybe the X goes here. It doesn't matter. So then I'm going to start my test, and something weird happened during this test, which I do want you to see. And also, when you get, right, they're asking you for a range, so you're going to get a compound inequality, right? You're going to get a compound inequality here. So let's take a look, right? We said we have the line segment AB plus the line segment BC. It's got to be greater than the line segment AC, right? I'm going to just go ahead and knock these out real quick. Line segment AB plus AC. It's got to be greater than the line segment BC. So I have AC, BC, right? Now I have line segment AB plus the line segment. No, I don't, bruh. No, I do not. That's a lie. The line segment AC plus the line segment BC has got to be greater than the line segment AB. I'm checking back through here. Like, I caught that, but I could have screwed that up, but I didn't. So let's do this. Line segment AB is X. Line segment BC is 5. The line segment AC is 9. Right? Just going to do some algebra here. Subtract 5 from both sides and get X greater than 4. So this is going to be an integral part of our solution. So I'm going to just put this in a box. Keep working here. And we get AB again is X. AC is 9. And BC was 5. So this answer goes to crap, and I just want you to expect this, and it's going to be okay. Subtract 9, I get X is greater than -4, right? Remember, distance in geometry, distance can't be negative, right? So in geometry, distance can't be negative. Actually, distance can't be negative anyway, but there's some argument about that in calculus with some people. All right, so this is just an extraneous answer. Just mark this out and just ignore it, right? This is just extraneous. Extraneous. So in my proof, I actually probably would write that. I would write this whole thing just like it is. So then I'm going to do this AC, which is 9, plus BC, which is 5, is greater than X, right? Add these together, get 14 is greater than X, right? So here's my pieces. Here, I have X is greater than 4. That's this one, right? Right? And just to show it, the inequality is pointing at the 4, so it still doesn't change anything. I just flipped the order. And then here, the inequality points to the X. Just making a picture for you. Is 14. So here are the possible values. So if your teacher or whoever said, is 3 a possibility? Well, no, 3 is not greater than 4 and less than 14. It has to be both of those things. Could it be 5? Yes, 5 is greater than 4 and less than 14. See what I'm saying? So this is the range of possible solutions. This is the range of x. Range of x values. All right, let's do one last one like I said we would, and we'll be done. All right, hopefully you can hear it and see it in your head. You're like, okay, Lindelof, I'm writing this stupid triangle. So here's my triangle. I'm labeling this joint out, A, B, and C. You can put anything anywhere. It doesn't matter. I'm going to put 8 here, X here, and 5 here. Going to do the same thing we always do each time, right? This is the most important thing you have, is to set up those 3 inequalities, and then everything will work out, right? So line segment AB plus the line segment BC has got to be greater than the line segment AC. I'm going to keep my AB just for my order. I already used I have AB. I haven't used AC here. Is greater than the line segment BC. Get to the last part, right? We have AC plus line segment BC has got to be greater than the line segment AB. Please stay with me on this. Check at the end. Do you have all of the possible inequalities? There are 3 of them. Make sure you have them set up correctly. All right, here we go. AB is 5. BC is X. AC, right? AC is this one here. AC is 8. Little bit of algebra here. X greater than 3 is going to be a part of our solution. One of these is going to turn out screwy, and we know that. We have AB is 5. AC is 8. BC is X. So you have this. X is greater than 13. If you're asking me, I'd stop right here. I swear to God I would, because this is the one that's going to turn to crap, but we'll do it. 5 is, right? AC is 8, sorry. AC is 8. BC is X. AB is 5. Right, this is the one that goes screwy. Subtract 8 from both sides. We get 8. X is greater than negative 3. Extraneous, right? So we don't need that one. So now we're just going to start this out. Here's X greater than 3, right? Because I can read this inequality backwards, right? X, if 3 is less than X, then X is greater than 3, right? And X is also oh, look, dude, see what I did? I was like, what the hell just happened? I flipped my inequality, right? I should have flipped my inequality, but I didn't. So forgive me. Like, what the hell did I do here, right? Because it points to the X. So I got ahead of myself. I apologize. So it does work here. Sorry about that. But it kind of goes to what I was saying before. I don't care how good you are at math. I think I'm pretty good at math. Doesn't matter how good you are at math. The devil is in the details sometimes. So just take your time and grind through this thing, and you'll come out with great answers, okay? Hey, thanks for watching the video. If you have questions or comments, let me know. And if you haven't already subscribed, would you please?